Hi. So today we'll be doing a video on implementing a ordered list using a binary search tree list. So it's called a binary search tree list. So it's an ordered list. It's from the classes that we made already. So in order to do this video or to learn this code, you have to have already watched the videos that we already made on the linked binary tree and the lists and the node classes and all that stuff. So I'd recommend watching those videos in order. I should be posting them in order, so just go back and watch those. So I've already started writing this class. I can actually I can start again, but I'll probably just continue with this. It's an easy class. It's a small video. It's not like a 4-hour or 3-hour data structure video. It's just calls a few methods that we've already made. So I've created a class called binary search tree list of generic type T. So you can do that. You can pause the video and copy this. So it's extends linked binary search tree of generic type T. So we've already made that class. So it is a linked binary search tree through inheritance. It implements a list ADT interface and the ordered list ADT interface. And iterable as well. So I am missing a few import statements. So we can just we can import java.util.iterator. Import java.util.iterator. Then we have some doc here. Binary search tree list represents an ordered list implemented using a binary search tree list. So the constructor here creates an empty binary search tree list. So we just call the class name, no parameters. We call the super reference to set up the parent's instance data. Then here we have the add method. It takes parameter t element. It adds the given element to this list. So we just call the add element method. What class is this from? This is from the linked binary search tree class. Okay. So this is going back to the linked binary search tree class. We're just calling a method we already created. We don't have to write any actual method. We're just making a call here. Then I'll continue with the next one. So we'll write some doc here and say removes and returns the first element from this list. So we'll say at return the first element in this list. We'll say public t remove first. We'll return remove min. So it's going to return whatever this is going to return. So we're going to remove the minimum element of the tree, and that's going to remove our first object in the list. So it's kind of like confusing. Not too confusing, but it's like, well, why are we doing this? We're just trying to create a list, right? We're trying to create a list, but it's really a binary search tree list. So if I could maybe just try to clear up any confusion here. So we're using a binary search tree to implement an ordered list. So we recall the list operations: remove first, remove last. Remove first, last contains is empty size. And specifically for ordered lists, adds the element to the list. So I really don't have too much information here. You can use it and play with it. It's just to help you. I'm not going to really test it because we've already done all these methods. So honestly, it's really just a binary search tree. It's from the Java Foundations textbook. I'm not really sure why exactly they had us do this, but they had us do it, so I'm just helping you guys with the code. It's not too important. It wouldn't be something I'd really worry about. You can test it out. I won't be debugging this with you. I'm just going to help you with the methods, because they're just one-to-one calls. So we're just returning stuff we've already done. So it's honestly, we've already done this, so it's no point of me really explaining it too much. So we can just see what else we can get from this at least. So after we have the remove first, we'll do the remove last. So it's implementing a list using a tree basically. But it's really just a tree. Nothing too confusing. So we'll have some doc here. We'll say removes and returns the last element from this list. Just think of this as a list, but it's really a tree. So like, okay, we're removing the first, so we're just gonna remove the min. Okay, we're gonna remove the last, so we're gonna remove the max. You know what I mean? The last element would be the max element. That's all they're really doing. So we'll say, okay, removes and returns the last element from this list at return the last element from this list. We'll say public t remove last. Then we'll just call our method return remove max. So just think it's a list, but think like a tree. That's all it is. So it's like it's a tree, but think like a list. That's all it is. Like that's all we're really doing. You know, it's basically the same thing. It's just thinking like a list. So we're gonna say, okay, well we're gonna call the method remove here. Write some doc. So we'll say removes and returns the specified element from this list. At param element, the element being sought in the list. At return the element from the list that matches the target. So we'll say public t remove takes a parameter t element. So we'll say return remove element and pass in the element passed here as a parameter. We're like double passing the parameter here. So okay, so we're going to say, okay, well we're going to remove this element, so we're going to call this method and say, okay, we're going to remove the element. We're going to call the remove element from the linked binary search tree method and pass an element. That's all it's doing. So it's really a tree. That's all it is. So here we'll say, we'll do the first method, so we'll say returns a reference to the final element in this list. At return a reference to the first element in the list. Then here we'll say public t first. Then here we'll just return find min. So we're just going to say, okay, well we want the first element in the list, so we're going to find the min. That's going to be the first element in the list. So here we'll say return a reference to the last element in the list. Then here we'll say, okay, we'll at return a reference to the last element in the list. Then we'll say public t last. Whoops. Public t last, so we'll turn find max. Same thing, just opposite, right? Like symmetrical for a tree. Then here we'll do the iterator method. So we'll say returns an iterator for the list. At return an iterator over the elements in this list. So we'll say public iterator of type t. iterator, no parameters. Then we'll say return iterator in order. So it's going to call the traversal. That's all it's going to do. That's it. That's it. We're done with this class. So our class is called binary search tree list. This is it's all it is. It's a tree, but we're thinking like a list. That's all it is. It's not linear. Well, you can think of it as linear, but technically I don't think it is linear. We're not going to be testing this out because we've already done all these methods. We've tested all of these already. So if you want to test it, you can create a main method. You can instantiate a list, binary search tree list. You know how to do that. Of type, we can maybe just instantiate it. We'll say binary search tree list. We'll just store strings in there. We'll call it list. So of type, sorry, not strings. Of type string. Name list points to new binary search tree list. Of type string. Well, we could just say here list.add. What do we call it? List.add, and then it's going to take a t element. So we'll just call it element 1. Or actually, we'll call it obj. Why not? Then we should compile it and it should work. So we'll just save it and run it. Unless I haven't implemented all the methods. Binary search tree list.java. Did I spell it wrong? It's okay, I call it binary search list. Can I refactor this somehow? Binary search list. I don't think you can see this stuff, but I'll just rename it here. Must have spelled it wrong, so I apologize if I don't think you saw me spell it wrong, so it should be okay. So binary search tree list. So I'll refactor that. Hopefully it works. I'll save it and run it again. Cannot find ordered list ADT. Ordered list ADT. Unless I deleted it by accident. You should have this file. I probably deleted it by accident. And I don't have the file on hand with me, so I think you should. If not, you don't really need to implement anything. We could just take it out. If you can try it with implementing it. You should have the file. If you've done all the videos, we should have that ordered list ADT file in your files that we created. I know we probably have like 50 files now, or more. But you should have that file if you follow the series in order, so you can implement that. I just took it out just for purposes to show you that, just to test it and see that it works, hopefully. And then after, if it does, let's see. Method add element class and link binary search tree cannot be applied to given types T. Add element. Oh, whoops, did I erase that? Element, so add element. Pass an element, save that. I thought I already had that. Okay, so it did look like it worked. So it compiled successfully. So what I was saying here is that you can implement that ordered list ADT. You can add that back, ordered list ADT, wherever it is, something like that, whatever we called it. We did create that class before. Like I said, watch the series in order. Keep all your classes in a folder where you can access them all and use them later. And if you're getting an error, you can move them to your desktop and move them back into your SRC folder later. You can do that by going into your users folder, C users, something like that if you're using Windows. If you're using Mac or Linux, like at least Mac I'm not sure, and for Linux I usually just use Windows to do my coding stuff. So pretty much just go back and watch the video. Watch the videos. We should have this class somewhere. Pretty sure we did that with the list ADT. We said ordered list ADT and unordered list ADT implements in the interface. So this is an interface. Sorry, not a class. Well, it's a class, but it's an interface. It's an interface, but we might have saved it as, it should be saved as the same file as a class, .java. I don't think your compiler would know the difference, but because in Eclipse and stuff, I don't think you can choose if it's an interface or a class. You can just it's the same thing. It doesn't, like for this, if you choose either or, it's the same thing. The file itself. That's what I meant. But yeah, just find that file. You can implement it, and you can use it like that. It should work. Oh, what happened now? Oh yeah, it doesn't want this here. So anyways, I'll see you guys in the next video. If this video helped you in any way, or if you want to see more free educational videos on coding or investing or trading stuff, you can support the channel by subscribing if you'd like. And I'll see you guys next time. Take care.